Hi, my name is Patrick Caiaccio, and for my final project, I examined the different coefficients of restitutions for various balls. So, what is the coefficient of restitution and why is it important to sports? The coefficient of restitution is basically a ratio of the final speed of an object and the initial speed of two objects after they collide. So the coefficient of restitution of a ball essentially measures how bouncy that ball is. In a perfect world, it just doesn't exist. A coefficient of restitution of 1 would indicate that the ball bounces back to the original drop height. And balls used for sports have vastly different characteristics. If you think about different balls like footballs, soccer balls, baseballs, they all have different sizes, shapes, and they're all made of different materials. This affects the way that sports are played, and this coefficient of restitution of these balls affects the way the balls react when they're acted on. The purpose of this experiment was to find out which ball has the highest and which ball has the lowest coefficient of restitution. The balls being used in this experiment were basketball, baseball, lacrosse ball, soccer ball, tennis ball, table tennis ball, and a golf ball. And originally, me going into this experiment, I predicted that the highest coefficient of restitution would be the lacrosse ball, and the lowest coefficient of restitution would be the baseball. This hypothesis was made off of the fact of just feeling the balls prior to testing them and seeing how bouncy, quote unquote, they would be when dropped on the ground. So the experiment procedure went something like this. The motion of the ball was tracked by the Speed Clock app, which was downloaded onto my phone, and the phone was mounted on a tripod that was fixed a certain distance away from all of the balls that I dropped. This distance was kept constant at 6.5 feet. All the balls were dropped from 3.5 feet or 42 inches high, and each ball was dropped 3 times, and the average of the bounce height was what was used to calculate the coefficient of restitution. This was done in order to eliminate any errors that could happen if there was a bad toss or a drop that had too much spin. Then the position data from the Speed Clock app was used to calculate the coefficient of restitution for each ball. So the calculations I used to find the coefficient of restitution for each ball is as follows. Like I said earlier, the coefficient of restitution is basically a ratio of speed. So when dropping a ball, the coefficient of restitution of that ball is just the speed of it going back up after bouncing divided by the speed of it going down. So using the kinematic equation for vertical motion, Vf squared equals Vi squared plus 2gh, you can cancel out the initial velocity in this because at the start and at the base, the velocities are both 0. So this turns into Vf equals the square root of 2gh. Then once you place that into the coefficient of restitution equation, it cancels out to be the square root of the bounce height divided by the square root of the drop height. Some assumptions that were made for this experiment was that the drops were perfect straight down with 0 spin, and there was no friction losses or air resistance during the experiment. The first ball that was tested was a lacrosse ball. This ball was dropped from 3.5 feet, like I said before, and the average bounce height ended up being 2.68 feet. This calculated out to have a coefficient of restitution of 0.875. As you can see, I have the speed divided by time graph that was calculated based on the Speed Clock app. And here's a video of demonstrating how the experiment was performed when the ball was dropped. The next ball that was tested was a basketball. This basketball had an average bounce height of 2.07 feet, which added up to a coefficient of restitution of 0.7. As you can see, the same graph is displayed as for the lacrosse ball, and then a screenshot of the app image of the tracker going up and down with the ball as it followed the motion of it. The next ball that was tested was a baseball. The average bounce height of the baseball was 1.36 feet, and the coefficient of restitution calculated to be 0.623. The next ball was a soccer ball. The average bounce height for the soccer ball was 1.58 feet. This made the coefficient of restitution 0.671. As you can see, the same two images are available showing the experiment of the soccer ball and the graph of the speed versus time. The next ball was a tennis ball. The tennis ball average bounce height was 2.26 feet, which made the coefficient of restitution 0.804. The next ball was a table tennis ball or a ping pong ball. The average bounce height of the ping pong ball was 2.52 feet. The coefficient of restitution for the ping pong ball was 0.849. And finally, a golf ball was the last ball that was tested. The average bounce height for the golf ball was 2.69 feet, which made the coefficient of restitution 0.878. In conclusion, I've created a table with all of the balls tested and the coefficient of restitution in order from the highest to the lowest. So the highest coefficient of restitution ended up being the golf ball, which was different from my initial hypothesis of the lacrosse ball. And the lowest coefficient of restitution was the baseball, which was spot on for my initial hypothesis of which ball would have the lowest coefficient of restitution. Overall, these results showed a connection between how sports are played based on the dynamics of the ball. Basically, what I found from these results is that sports that utilize the compression of the ball have a higher coefficient of restitution. Sports like golf and tennis, which require the ball to be compressed in order to hit it back or hit it down the fairway, had a higher coefficient of restitution rather than sports that have a more of a focus on shooting or throwing, such as basketball, soccer ball, and baseball. These balls all had the lowest coefficient of restitutions. Possible errors in this experiment included the ball not bouncing perfectly straight up and down due to human error of me dropping it when I was testing the balls. One of my recommendations for completing this experiment again would be to construct a sort of platform jig to drop each ball perfectly straight down without spin. Creating a jig rather than having my hand dropping each ball would eliminate minor discrepancies in how high the ball was dropped. And this would make your results slightly more accurate. Overall, though, I feel that the experiment went very well, and it was able to open my eyes to how different sports are played based on their balls and what the coefficient of restitution are of those balls. And overall, it was a very successful experiment. Thank you so much.